Yeah, baby. Welcome to the video, guys. I did not include you in the beginning, but this all started with Wisconsin engines being available for $2,000 on Facebook Marketplace. And I went and I met up with the guy, and he said, these are good, reliable, air-cooled engines, 65 horsepower, and I thought, wow, I've been meaning to get something, maybe an engine for this chassis for a while and build a stump grinder with it. But I don't see any other stump grinder videos online doing one quite this size. So the old gentleman threw in a pump. That's like $1,000 pump. Came off an old skid steer or something, and threw in a reservoir for me, filter housing. What else did he throw in? Cylinders. So I already did some work on this. This is my extension cylinder. You'll get to see that in a future scene, okay? But this component here got cut off from that, and then I actually have material that goes all the way through inside there. So now I can extend about 3 feet. Alright, so today these pulleys came. These are called sheaves, and they pronounce them shivs, actually. I've seen the videos. They're called shivs. These are expensive. These are cheap. Kind of interesting. So I guess something really special goes into making these. But I had to buy this. This one came off my old machine. I just had to buy a special bushing for this, which it would have almost been the same price to just buy another sheave and buy this style. These bushings are like 30 bucks. This is quick disconnect bushing. That's like 250 bucks. And that's like the price of the pulley. Like this pulley was probably 400, 350 or something for this big pulley. So a lot of money there. And I've got my hydraulic components in this box here. This is a wired system. So I've got my engine mounted right now, but I don't have any ability to rotate this. So I already mounted my pulley on. I already established mounting holes for my pump. And then I installed this small pulley right here, which may need to be replaced with a different style because the belt wants to rub on this. But we already strapped down our reservoir. We made sure that our volume was about right for that. And we just need to get hydraulic hoses and hook up our valve controls. The way this is pictured online, I thought it came to you assembled, but you have to put it together and all these components that you have to kind of figure it out, but it's not rocket science. There's a port that goes to nowhere right there where my fingertip is, and there's a P on the side of the valve, or the spool valve here. So the P just is supposed to point this direction of the block. So now it looks like pressure ports are connected. So pressure to pressure, and then T is tank return. So all I need to do is apply pressure. Let's see if I can show you this. Hydraulic pressure in here, and then return to tank here. So the way I'm setting this up, I need to run pressure from the pump, needs a bypass before it gets to the spool. It needs to go to a relief valve, and then I need flow control. So the flow control controls basically everything after the pressure relief is going to be flow controlled. So if I reduce the orifice size to the point where the pump is basically generating too much flow, then this relief valve is going to allow that to return. So I actually need a T to go in here. Limits pressure at port 1 on bottom by relieving to port 2 on side. this point I need to establish a location for this block. So I kind of lean towards having the controller on this side. And my hydraulic pump is here. Reservoir is here. So it's kind of cheaper in terms of hydraulic hose to go in this area. But I scored already this location for something else. So that tank is right there. It's not ideal. The block would be better suited right there, but I could always build something and place the block up above that. Thing is, see, everything comes out of this block in these ports right here. So all these hoses need to extend, you know, without really crashing into anything. So it almost makes more sense to build a structure on top that raises it up a little and just have it based over here somewhere. Doesn't really need to be up high necessarily, but just for access purposes. Because if it's over here, and I got my harness. See, this harness has limited length, but this is the relays. So there's a couple feet here. Might as well hook this up now. One great feature of the electric over hydraulic system is that you can move this remote to anywhere you want without having to make changes to your hydraulic actual hoses. One thing I've noticed building this machine is that there's nothing that I don't have to do. Everything has to get thought of, including protecting battery wires, preventing abrasion, and preventing things from generally self-destructing. So there's actually a lot that goes into this stuff that I hadn't conceived of prior to this project. Just a little example of some of the fabricating that goes on. I'm not recording all the welding and stuff, but this is kind of a cool, easy part to see. Ah! Ah! Jeez! Ah! Yeah, I just got hurt. Ah! I'm not injured, I'm just hurting. Oh yeah, look at that. Either way, it's gotta come off. I made many attempts at starting this engine, probably at least 8 or 10. Could not get it to fire, but it turned out that the engine wasn't getting fuel because maybe there's a leak, air leak coming into the fuel somewhere. So I just give it a little air pressure in the fuel tank and it starts. Boy. Hydraulic system's working. So now I have hydraulic system pressure, I have a control valve, I have switches, I figured out how to tension my belt. My belt was too loose. I'll probably have to change that whole thing again after this because that engine is actually going to move to tension its belt. So yeah, that's going to have to get adapted a little bit. But yeah, I'll show you around. Kind of hard to organize these hoses, I will say. I think you need a couple tries to get these right. This big hose is too short. It only reaches, and you can even move this a little bit and see that tank flexing. So I can clean this up and then set it to where there are bolts holding this thing to a piece of steel. The swivel is going to go somewhere underneath right here. And once we have the swivel, we're going to have all these other parts too at the same time. The jack shaft, which is going to be around this area. So that's all going to be all at once. But yeah, we've got extension and contraction now. Engine's a little bit hard to start, but these switches are really nice to use. I love them. Drilling these holes is a very physical process. it probably doesn't look like a big deal, but if you've ever drilled sheet metal with any large size drill bits, you know it can really hurt you, that drill. So it's an agonizing process. I'll spare you the full detail of it. Just see a couple of these. I have my ring of holes. That's the small diameter. I seem to be very lucky. I avoided these rails for every single one of those holes. These are all threaded, and they correspond to these countersunk holes. These need an Allen, like a socket cap screw in them. And then you can see these ones here are threaded. So I will be bolting this one from underneath. This can be hex screws. I'll probably just use hex grade 8 for those. I ran into a little hiccup here. So this is my intermediate, this is my jack shaft right here. And I had the right bushing for this old pulley. That was an arm and a leg for that bushing. I could have got the pulley and the modern style bushing for probably the same price as that bushing alone. But that's an obsolete style apparently. This is the new style. It's called taper lock. Does the same exact thing, but apparently this is better. So this shaft is 2" right here, and at the end they're 2", and this is 1 11/16. So I don't have the right bushing for this 2517. Anyways, you can see this is a 2" bushing, and the measurements are on the bushings. There's a 2" right there, and then this one is 1 11/16. So sadly I made an ordering mistake. I'll need to order that correct bushing and then return this hopefully, and I might need another sheave later, but I might change that. This piece here, I really didn't want this to be on the final drive component because it was so big, but I'll work around it. I had to get my ratio. I was running from one this size, which is the smallest one you can get, to the size that I already had floating around the shop, and then I'm going from a small one again to this big one to get my final ratio. So if I find out this needed to be smaller to get the right speed, I'm going to be bummed because I spent like $350 on this. But we'll build the machine around it. That adds weight too, that adds rotating mass to the cutter wheel. So it's not hurting me so much. It just needs to be installed right. And, you know, this slew bearing, take a guess, how much is this thing? If you guessed $2,500, you'd be right. It's got to be some special technology in there, special manufacturing or something. It's very special. It's got a bunch of greasers on it. 1, 2, 3, 4, 5, 6 greasers on it. I'll have to make sure I get instructions for that thing. Pillow block bearings. There we go. Look at that, my friend. Huh. That's interesting. So this one fits the main shaft. So see if it goes on here. Yep, goes right on. And then the set screws hold it from coming off. Just tighten this like that. Yep, that looks about right. go. That's how that works. I got the bolts finally to install this slewing ring. But, you know, I was looking at the Carlton machines when I was in Chicago, and their steel was like, you know, 1/2 inch, 3/4. I mean, they used a little 3/8 steel, but a lot of their steel was super, super heavy. And I called Carlton and I asked them, how much does your cutter head weigh? not the cutter itself, but the framework. And they said, like, just the framework without the wheel weighs like 350 pounds. Yeah, so 350 for that. And then you got the cutter wheel assembly, that's another 300 and change. So it's about 700 pounds hanging off this thing. And it's all got to be supported by this plate. And I'm like, I wonder if my little plate can take it. I just wonder. It's a great question, right? And then, you know, the guy was like, he's like, well, I can't really tell you a lot of this stuff. He goes, it's very proprietary, you know, it's very secretive stuff, so I can't tell you all of our little trade secrets. He goes, but he says, but it does need to be done right, and he says a lot of times you have to go back and revisit something to get it right. That was what he told me. I thought that was very good advice. It was very polite of him to tell me the way that he did too, because, you know, he could have been a lot more rude in the way that he presented it. Got it. Yeah, baby. I'm going to spare you guys. I did not show the install of this engine. It's kind of a headache, and I had my worker there helping me, but it was not too hard. And here I'm just piping this filter housing into a better spot. I welded a little cap on the end of this thing right here, because that is where the oil is going to go when we drain the oil. So I want it to come out the front of this tube right here, and we can just put a drain pan under it. So for this engine, we have this drain. We also put like an elbow right there, and that allows us to actually access this square. And we cut this slot in this area to allow that to go through, because that piece actually hangs down too far. And yeah, and then I had to put a brace for my hydraulic tank, because we were running into troubles where my main supply hydraulic hose, this one, was actually pulling on the tank. This is kind of an old beater tank from an old machine, farm machine. So I just piped it straight to that and then hooked it up to a brace, and I'm able to hook these all back up now. So there you go.
That is awesome, babe. Oh my goodness, there's such a wide sweep.
I know.
You're gonna be able to eat such big stumps.
Well, it's gonna be out to like here. So it's probably gonna be almost too wide. I mean, it's gonna go out past the wheel. It's gonna go so far. It's gonna go out to probably here, like at my feet. So I'll be able to do like all this. Like everything between these wheels can be grinded. But I need to set these. I need to set these pins up to have an actual big metal piece.
Okay, yeah, it's kind of jimmy rigged with a bunch of
It is jimmy rigged. I need like a big piece of steel that's heavy and thick and 3/4, and then maybe I'll have a drill. I'll drill a hole and have a greaser in there so that when it spins, it doesn't damage anything. It'll just spin on the. I mean, it's fine to have a dry linkage, but it'll wear out over time. So I'm definitely going to have to figure out something with this dry linkage here. I'm going to have to brace it because as soon as it starts pushing, it vibrates all over the place.
Yeah.
Like this thing goes doing.
Oh yeah, you're going to need some moist.
And then that thing like has, you see the slop? That's from having the holes not precise. And so what I want to have instead is a tube that's the perfect size for these little shafts. That this can spin inside it, and it's the perfect size, and I can put grease in there so that they can turn over this and it'll be smooth. Well, I didn't want to bother you guys with the details on this, but actually I was too busy to film. I got a couple extra hoses, and I hooked up my hydraulic to this. It's 16-inch stroke, so I found a post that would work, and then I was lucky. I was able to find a position where it's roughly moving this engine correctly. So these pins are on this very thin metal. It's just temporary, and it really needs to be a big piece of like 3/4 steel, maybe some grease fitting or something in there. But when you run this thing now, so I forget if I mentioned this. I made some changes to the steel that holds down this hydraulic. This belt right here is kind of destroyed because it was running on this side of this engine at one time. I used some cheap like pre-made hoses from Farm and Fleet, and I just put the ends on them. So these will be cheap to replace. They're gates, which is probably decent, but they're too long, so I'll probably end up replacing. It'll be $50 to get 2 new hoses for this, and these won't be all ridiculous and long. And I just hooked all these up. I was kind of like feeling retarded because when you hit the button, the light lights up, so you can tell what button goes to what block really easily. And I was like meter testing it, which is kind of funny. But I ended up getting my final positioning for the table, which means that I could set up my correct fuel line length that I needed, and I like having this up here kind of. It flexes a little. This kind of still isn't perfect. I might have something like holding this back, like some kind of a spring. But these generally move how they're supposed to. They're not really causing me trouble. It's just a little scary that all this would be exposed to the outside, so I'll probably have to put like a shroud or something. You know, these relays are probably weatherproof, I'm guessing, but that doesn't mean you want water all over them. You know, and this hydraulic stuff, I mean, that probably endures fine, but rust, I don't know. I'm not as worried about like the hydraulic cylinders. This tank is probably fine. I'll just paint I'll probably do a nice job and sandblast all this steel after I get the welding done. I'll paint. I need a new belt for this. This belt is eaten, see? It's destroyed, so. This is going to be the end of this stump grinder video, guys. I just wanted to show you the initial process, the startup. I'll show you more when I get the next parts, but I just wanted to share this process with you. I'm not trying to make like a super fancy pants video. I just want to, since I'm making an amazing machine, I figured it was worth sharing with everybody. But I'm very focused on the actual work that's going into this, and since I'm doing everything by myself, there's limits to what I can video. But it's fairly simple. I mean, you implement, you know, you have to solve different engineering problems, like how fast things are supposed to turn, what are the pressures coming out, stuff like that. And once all that stuff is figured out, it's pretty easy. The trailer needs to get wired, the whole like jack shaft and the pivot and the head framework assembly, and then the adjustments for the head, the mounting holes for the bearings, that all needs to get done. It's all got to get done in very heavy steel. I initially, for some reason, I was thinking I would be able to get away with much smaller steel, and after I actually saw some machines, I realized they're using very, very thick steel, 3/8, half-inch, 3/4 for a lot of it. And so on these major structural parts, I might have to actually go back and rip this engine off, take off the cutter assembly and everything, and lift it off, and then put a bigger platform, a thicker steel platform. Maybe this platform isn't rigid enough. I did put some reinforcements there, but that doesn't mean that it's going to work. I mean, it could tear out those bolts where those bolts are threaded in, and then I will just have the whole head just falling forward and breaking off. And then when it starts to do that, the whole thing has to get ripped apart. But the good news is, once I have a design, if it's too thin, I can take that and I can just make that exact design in a machine shop, and it'll be so much easier. And then it'll just go in, it'll get work done, it'll come out, it'll be perfect. Everything will be good. So if that happens, and that's what I'll do, and I've got, you know, kind of a plan for how I'm going to do all that. But yeah, there's always going to be changes along the way. One of the major engineering problems on this machine was the pivot. How am I going to pivot left to right? And I couldn't find kingpins that weren't like a proprietary design with a bunch of components that were pre-welded, and I didn't know. So I just bought this turntable, which was a very simple application. You just simply drill the holes, you thread it, you put the bolts in the other side, and the thing goes together. And you have like 6-8 grease zerks on it, you grease it, you take care of it. It's basically a lifetime part. The other engineering problems I'm having troubles with my hydraulic system. I can't figure out how to get my hydraulics to flow slower or to move the cutter head slower. For some reason, it wants to move the cutter head quickly, and that is causing me trouble because, of course, as I'm grinding, I want to be able to go slow, and so you have to have a control valve. And there's a relief that sets the pressure of the system, and then there's the flow control. And what I've discovered, if I close up that flow control down to a smaller flow rate, then the pressure side of the system goes nuts. I don't really know what I'm supposed to do here. I mean, I've got limits. If I take off the relief valve, then I'll be in trouble when I set the flow too low. You can probably do this with just one or the other. This makes me think I might be able to do that. But this is an engineering problem. You have to understand the flow rates. You have to understand, I don't understand any of that stuff. I don't know the mathematics. And then there was another one. There was the drivetrain speed had to be established, and so the pulleys went from small to big, and that's how you get a slower shaft speed. And so I actually had to reduce twice, and I had a jack shaft anyways, so I'm having 4 pulleys in total, and there's 2 pulleys on one shaft that goes down to the next shaft. And so I had to establish my pulley sizes. My pulley sizes are quite big. If I want to have a different wheel size at the end of the day, I'm going to have to change my pulley sizes, which means I'm going back to the drawing board. I'm figuring out what belts to get. The belts might have to be longer, shorter. I don't really know. I made a mistake on my ordering of one of the bushings, and the bushings are not too much money, so I just had to order one. But if I get another pulley, that could be hundreds of dollars. So, and then the other engineering problem I'd like to solve, but I don't know how, is that the tongue doesn't, I don't know if the tongue really goes out far enough for my liking. I would love the tongue on this trailer to go out like 6 feet, but it goes out 3 feet roughly, 32 inches. So I would, if I want to do any more than that, I would need more steel, I would need a different design. I feel like 3 feet is still satisfactory for the majority of stumps. the plan is I'm going to put backup camera and I'm going to put it on the stump grinder, and maybe it'll be like a magnetic temporary one, maybe it'll be permanent, but it's going to be a Bluetooth device, and it'll connect to my phone, and I can look at and back up into the stump and line up perfectly and make sure that that stump is lined up. Otherwise, you know, I'm going back and forth a little bit on people's yards. It's not the end of the world if that happens. Some of the time I'll be using this machine with a bobcat, and I'll just literally put the bobcat there with a ball and we'll just push it in and out with that. So what other engineering problems? Oh, we had a rigidity problem with the hose pipe where it comes out of the hydraulic tank. It has very thin walls, and so I needed to change the design where the filter housing is actually mounted to a piece of steel, and so I just routed some pipe around there, and that took care of that problem fairly easily. You know, the switches, I'm gonna hotwire into the switches with a it's gonna be a remote, and it's just gonna be like a pre-made remote that has a bunch of functions on it, and I'll just either label the functions or I'll just memorize them or something, and it'll have a receiver and a remote module. Maybe it's rechargeable, maybe it's got batteries, I don't know. But rechargeable would be nice, and then like rechargeable batteries inside, maybe like a AA style, and then you could put rechargeable batteries and just plug it in. That'd be a cool design, something like that. But they're on Amazon, they're not too much money, and if you go heavy industrial with those things, you can spend thousands, but it's really not necessary. All you need is something that works, that you can replace and engineer a new one into the system if you need to. It's not hard. I mean, all you need is 12 volts to a wire, and that'll engage one of these relays, which sets up the solenoid, turns on the solenoid. Yeah, I don't know, other engineering problems I'll run into is going to be like vibration after I begin to build my cutter, my actual cutter frame assembly that goes out, the main arm that goes up and down, because I found out that the wheel size I'm using, those companies that use that also have a really heavy duty shroud that weighs like it's like 350 for that, and then the cutter wheel is supposedly around 200 pounds. And then the summary that they told me it was around 700 pounds for the total assembly together. So if I'm hanging out, you know, 700 pounds out, you know, you're gonna have a stress problem. Anytime there's any vibration, that's gonna stress the welds. That's gonna stress all the different components, mostly the welds, the fabrication. And so there's some engineering. And so I'm copying, I'm borrowing, I'm looking at their designs and stuff and their parts diagrams, and I'm gonna try to do my best to try to make something that will do the same job. So yeah, that's it. Other than that, you know, the engine can be a little touchy to start up sometimes. Like when you first try to start it, sometimes it'll have, like, the gas will seep back down, and the best way to get it started is to blow a little compressed air into the fuel tank, which gives it a little boost for fueling. So, you know, you want to get some fuel pressure there. So I might put an aftermarket fuel pump on this, but I don't want to ruin this engine, so I have to be super careful what I do there. Once it starts, it runs great. It runs amazing. It revs up and everything. I can't believe there was ever a 65 horsepower engine that didn't have like a radiator and water cooling. It's truly amazing. But yeah, it's going to be really hard to run this grinder with these switches the way they're set up right now, because that thing is going to just be shooting stuff in your eyes. And the normal design is they put a big shield right there that folds out, and then you stand behind the shield. That's pretty much it. I'm just, you know, just living my best life over here. So, alright, well anyways, before I go like messing around with stuff now, I'm going to just tell you guys, have a great day. Thank you for watching this video. Don't forget to like, comment, and subscribe.